So, hello everyone. Thanks for the kind intro. So, my name is Naor Kalbo. I'm a principal researcher at Cato Networks. And today I'm excited to talk about what I like to call the contextual agentic garbage collector. Well, think of it as a smart sweeper that helps us clean both minor and major misconfiguration crumbs before attackers ever get the chance to exploit them. We will dive into how we identify these contextual misconfiguration issues inside very critical systems like firewalls by analyzing the context around them as a complementary level to the traditional, well-known industry configuration analysis we are familiar with. We will start by introducing the problem domain. We will move into the detection layer, and then finally, the first ever introduction of the complete agentic framework, which will get somewhat technical. So buckle up and let's start. So a little bit about us, only for the sake of the talk context, no marketing, one short slide, I promise. So Cato is a company in the SASE space, basically the convergence of security and networking together. Our product essentially takes all of our customers' network and security infrastructures and move it into the global private cloud with the full inspection capabilities and all of it managed by us. So essentially, this lets our customer to enjoy a single unified platform that covers all of their organizational needs instead of juggling a collection of point solutions, right? So let's talk about the problem space we are trying to solve. According to Gartner, 50% of the cybersecurity incident in organization will stem either from lack of talents or from human failures. And this isn't some distant prediction. It's already happening today. And if that number alone isn't concerning enough, let's add it to almost 3.5 million unfilled cybersecurity roles across IT, CISOs, AppSec, security engineer, you name it. The result is that the pressure on IT and the security teams, which are often already understaffed and very small, is actually skyrocketing. And that rising pressure creates a very vicious circle that both explains and fuels up the search for security incident that we are seeing today. So when we are talking about AI and automation, it's no longer a luxury or just a proof of concept experiment that we are trying to have. It's becoming the real organizational business needs to close the gap that have been building up for years for all sorts of reasons. So in our platform, the users, like the IT managers and the CISO we referred earlier, they define the desired behavior or they apply the company policies in areas of security and networking through the policies they create. This policy covers a wide range of products, such as WAN firewall, LAN firewall, CASB, DLP, and many more. And essentially, a policy is no more than a set of rules, with the flexibility, though, to define multiple dimensions for the desired behavior. So, as much as powerful as this mechanism is, it is also plays a critical role in the system, where the margin there for an error can be very significant. And that's why a proactive oversight for this specific mechanism can play a key role in minimizing the potential future damage for the organization. So we have decided to bring together two worlds. The world of the policy from the first time, and the world of AI. AI capabilities allow us to build an autonomous system that continuously monitors user configurations and can highlight the potential failures early in the process. And this world's convergence opens the door to some very powerful new types of insights, starting with the detection of contextual misconfiguration, which is a whole new set of security issues that live in the semantic dimension, to the ability to suggest optimization, not only at the level of individual rule, rather across an entire policy. And in some cases, might consist of thousands of rules. In this session, we will be focusing on the first type of insight, the contextual misconfiguration. So when we step back and we look at the bigger picture, it's clear that operational security teams need help. That's why we built a new agentic AI engine that layers directly on top of the policies mechanism we referred earlier, like the organizational firewall, which we provided Cato. This engine essentially works proactively and continuously to improve the organizational overall security posture. So what that policy mechanism actually looks like. So at its core, it's a list of rules, right? This is the policy, a list of rules, where the order matters. And each rule defines a very desired behavior. So let's take a firewall, for example. We can see the rule name, the rule description, and a range of rule misconfiguration and definition. I'm not sure that you can read, but let me make it clear. The rule name for this one is allow remote access to Ireland. And the rule description there is this is requested by the finance team for the due diligence efforts, some due diligence efforts. And there are many other technical configuration for the rule service, the ports, the application. We can think that if it's a remote connection, maybe we would like to allow some VNC or RDP services. And essentially, we do have the action, whether we would like to allow it or to block it, to monitor that, you name it. So assuming a customer might have hundreds or thousands of this kind of rules, what does this engine actually do? So the main features essentially are applying semantic analysis on a free text to identify the contextual configuration issues that usually wouldn't be caught by any traditional configuration analysis. Why, you ask yourself? Simply because it's not possible. We are doing that by examining data types, such as the rule name, the rule description, the associated tickets for that specific rule, contracts, wiki pages, Confluence pages, and basically any other documents relevant if there are any. Ultimately, we are taking a huge burden of our customers' shoulders by essentially introducing this agentic engine as a true force multiplier in their organization. So the semantic and the behavioral engines I just talked about, we have developed can generate many types of insights, which we will cover shortly. The first one is the detection of temporary rules. So what is a temporary rule? Temporary rules are firewall rules that we have found were identified that were created as a short-term solution, mostly to address an immediate organizational or business need. Let's see some examples of the insight that we have found as temporary, rules that we have found as temporary. As an example, a temporary rule that granting the R&D team open network access during internal hackathon event. Again, open network policy. So I bet this one shouldn't be there at all, or shouldn't be there at least and need to be removed as soon as possible. Another example of temporary rule is a temporary rule that allowing sensitive protocols or application like RDP for the sake of POC for a third-party contractor within the organization to complete some projects that they are currently having on the system. So let me emphasize that sensitive protocols or application that were meant to be allowed only during the POC phase. So think how insecure it is and dangerous if that POC has ended, but that rule is still there. Another example is a temporary rule that blocking or allowing access from specific geography due to some global event, right? And another one is a temporary rule, which actually it's an exception for a user, let's say his name is Ethan, that conflicts with the company policy, like enabling telnet, which I assume we all agree that is insecure. And why is there? The rule is there because Ethan just asked this one to complete his hacking course. And the organization, essentially the IT, need to provide that, or to complete some project in the organization. So as you can see from this example, detection can range from simple semantic cues like spotting the word temp or temporary, all the way to more complex context-based scenarios, such as understanding POC as something temporary, ad-hoc, contractors, the semantic meaning of analyzing the rule name, the rule description, and every aspect on top of it. Another insight type is the testing rules. So detection of testing rules, this are slightly different from temporary rules. These are actually firewall rules that we have identified as being created mainly for validation, for debugging, or to experiment with some specific feature or organizational scenario. Let's see some examples. The first example is a testing rule that's created to help to debug a network issue. And we all know that while debugging, we are very generous about our non-restrictive approach. Seriously though, this might be ended with a major security gap in the organization. Another example is a testing rule created to explore and to get familiar with some certain policy configuration, like allow any rule, which might be legit at first. We saw that at customer because they don't know how to configure their firewall at first. They want to learn, they want to allow everything and then to scope it down. But as much as this might be legit at first, it must be dropped as soon as possible. And we see many cases where customers actually forget about it. And this is a real major issue in their network. Another testing rule is a testing rule that created to reproduce and to validate some past incident on the network. Such an example as an old IoT device that communicates between the IP cameras and the DVRs, right? Which legacy configuration would have a really hard time to detect that as non-relevant anymore. And of course, all of that is essentially inherently multi-language. And obviously, it's depending on the LLM model in use. We have seen testing rules written in multiple languages. For instance, a Chinese testing rule that is for verification on some old domain controller, or a French testing rule for demoing the RDS feature. Another Spanish testing rule that disabling the block of risky Gen AI application. And why? Only for the sake of evaluation and risk assessment being done in the organization. Well, this might be legit to a certain period, but it significantly increases the probability of this configuration left forgotten as it is, which in turn might consequence a security breach in the organization. The third type of insight, and in my opinion, one of the most unique ones, is the detection of expired rules. These are firewall rules that we identify as they are having a very interesting pattern in the data. Customers tend to create their own visual or textual indication to signal some desired wishful cutoff date, again, cutoff date for the rule. So this cutoff date could be tied to an exact date, a period, or even some conditioned by some event, right? And this is actually pretty fascinating because it's something that is very hard, even impossible, to capture with traditional heuristics methods. So for example, a rule that allowing a marketing employee TikTok access until her marketing course is finished with some point of time, wishful point in time. Another example is rules where we have detected an expiration sentiment embedded within the text, the rule name itself. In one very, very interesting case, we have identified rules marked with EXP as a signal to expiration or expired, and some free text of a wishful expiration date with a high degree of variance. And this is very individual convention. We have found among thousands of rules in our customer base, which actually only contextual analysis can spot. One time it could be EXP, the other customer might call it differently. This is the true power of leveraging AI and LLMs in order to spot that kind of issues. Another examples is rules that were likely to become irrelevant once some specific target date was reached. And for instance, when patching efforts were completed or when some particular issue was resolved. And here, the agentic framework, the agent, can increase the detection confidence by dynamically acquiring additional knowledge about the project, specific patching effort from Jira ticket, from Wiki or Confluence pages. Think about that, and we will see that in a second. And on top of that, a very interesting challenge we have tackled here, specifically in this kind of insight, are rules that might be conditioned by holiday or event. And the holiday and the event actually are textually included in the text, such as Thanksgiving, 4th of July, Black Friday, or even Super Bowl. And ultimately, the semantic engine should both detect and resolve them into a date in order to pinpoint them on a timeline to determine whether they are expired or not. So as you can see, the semantic and the behavioral engine can actually generate multiple types of insights. The temp, test, expired, as we discovered, as we actually covered during the previous slides. But there are also some very interesting other types that currently out of scope for this session, but yet it's still worth mentioning. The first one is contradicting rules, where actually two or more rules have conflicts of intention, potentially causing misconfiguration in the organization the overall applied policy wish to be. Mismatched rule is a rule where mistakenly configured with the wrong action compared to the semantic meaning, the intention. Let me give you some example. A CISO or the IT can actually define that they are not allowing VNC in the organization. So they create a new firewall rule. They're saying block VNC in the description according to policy, blah, blah, blah. Define the VNC port, define some applications, and then mistakenly, it chooses to allow in the action. This is something that is very hard to detect, but using the semantic, the LLMs, the power of AI, to do some semantic analysis and to compare that, the intention, the real intention versus the actual action can help us a lot. And we are digging a lot of misconfiguration using that way. Another one is over-permissive rules, which actually a rule that is configured with a too broad of scope and unnecessarily increasing the attack surface in the organization. So what actually do all of this new AI-driven insight have in common? They bring improvement across two key dimensions. The first one is the improvement in the detection quality. We are talking about rules that would be very hard, very difficult, almost impossible for traditional analysis to identify as a security threat to the organization. And remember the stat we mentioned earlier, 50% of security incidents in organization stem from this kind of issues. And the second improvement is the improvement in the detection speed, the MTTD, the mean time to detect. And in a standard scenario, this specifically, this rule that we saw would be probably only be discovered during an audit. Maybe once a year, in the best case, once a quarter, or worse than that. They could be found too late, after they've already been reconnaissance or exploited by threat actors. So up until now, we have gone in details for different type of contextual misconfiguration and how they are even within the policies, like temporary, test, and so forth. These are the crumbs attackers eager to find, and they invest endless resources to do so. What we are doing is we are delivering the sweeper. We are delivering the sweeper to clean these crumbs away in advance. So in the next slides, I will present the agentic framework that makes all of this magic possible. So let's get to know the building block of this framework. So we're building multi-agent architectures there are several ways to connect the agent in the system. Think like you just mentioned in your talk. So we do have the network-based connection. We have a single agent, or to use a single agent, or hierarchical setups, or the supervisor approach. For our use case, we have found the supervisor approach as the best fit. The supervisor is the core agent in the system. All the other agents communicate with it. And it, the supervisor, decides which agent should be called next. Its role is very similar to traffic controller, orchestrating the flow, deciding who should execute and when. The supervisor can trigger the process either by scheduled timer or by detection of changes in the policy. It also includes tools that assist, for example, in account lookups, pulling valuable information such as whether the account is active or not, which policies are in use, and so on. The supervisor can assign, can abort, or retry tasks for each of the agents you will see in a second. And in cases where human judgment is required, the supervisor knows to request human-in-the-loop input. Finally, it is responsible for storing and publishing the insights that have been found back to production environments. So this is the supervisor. The next building block is the data retrieval agent. The data retrieval agent is responsible for the data gathering from any given policy in the system. And they are doing that, the data retrieval agent doing that not only for internal, but also for relevant enrichment that might be external as well. This agent has several tools. And I'm not drilling down into how tools are communicated, but just to give some sense, it could be communicated with MCP, for example. MCP, Model Context Protocol, is something that is very hyped right now, but this is one way we can actually use the LLM, ask for a specific tool to be used. So this agent, the data retrieval agent, it can actually fetch data using some GraphQL queries that we are using in our backbone. So this is why GraphQL. And it can also check and pull for enrichments from third-party services. For example, contextual ticket enrichment from ServiceNow or customer interaction from Zendesk. They are very loaded with textual, with a contextual that can help us a lot when we want to decrease the false positive and to increase the accuracy in our system. We don't want to create the alert fatigue. We are very cautious about that. And gathering data for the analysis of the context is very important for us. So the agent also leverages an LLM, obviously, for several enrichment use cases, such as distilling the most relevant part from long text, like tickets, Jiras, Zendesk, whatsoever, performing name entity recognition, and generating summaries. The next agent, which actually all these agents lies in the next agent, the core detection functionality lies within the detection agents. So there are several detection agents you will see next, each assigned to detect and investigate specific insight domain. You can think of each one of them as an expert at his field. So one example in our framework is the temporary rule detection agent. we have seen earlier, right, with the temporary rules. Its goal is very simple, is to detect and investigate temporary rules within a given policy. For the LLM backbone, in all of the detection agents, we choose to leverage Claude Sonnet 3.5 through Amazon Bedrock, which basically, in our testing, it consistently delivered the most reliable and long-term stability. And this agent is equipped with a range of tools that essentially allow it to further investigate a potential temporary rule. Its purpose is essentially to confirm or disapprove the relevance of the finding. Some of the tools that we have equipped this specific agent with is contract management platform tools like DocuSign, for example, which these tools are essentially responsible for adding context around POC rules related and cross-validating them against actual POC contract that is happening right now in the organization, minimizing actually the false positive potential. Another set of tools is the ticketing system tools like Jira, which they are responsible for validating employees' requests for temporary capabilities, like we saw earlier, like Ethan that asked for Telnet. And we are doing that by using the Jira ticket to analyze that's essentially being sent to the IT or the AppSec team. And lastly for this one is internal wiki tools like Confluence, for example, which are responsible for gathering additional knowledge about internal projects, about internal pipelines, about internal RFCs. And this is very important for the contextual aspect we are trying to analyze. Another detection agent is the expired rule detection agent. And the reason I'm showing that is just to clarify that each one of them has a different purpose, has a different set of tools, has a different capability, system prompt, you name it. They are all customized in order to perform some very specific action. So as we all know, LLM can sometimes struggle with tasks that involve comparisons, right? Or time-based operation. So this is why we actually equipped this agent with a set of specialized tools. Time function tools, which are responsible for determining the current time, handling different time zones, or even perform some accurate date and time comparisons, which LLM are pretty about them. Another set of tools is the holiday and the event tools, which are responsible for resolving non-deterministic dates, such as we mentioned before, Easter, Black Friday, Super Bowl, each of which, by the way, they falls on a different date every year. And we need to spot that. We need to define and we need to pinpoint a specific date. LLM couldn't do that. And a very important agent, the last one, is actually the judge agent. So this agent is essentially responsible for this decision-making around the insight generating by the other detection agents. The judge receives all the insights and must decide whether they are relevant or not for the user. Its decision-making process relies on 3 pillars. Noise reduction tools, which are responsible for handling and filtering out high ambiguity insights. This is a very difficult problem. Conflict resolution tools, which are responsible, obviously, for investigating conflicting insights and making sure that we are doing some very informed decision between them. And prioritization tool, which are responsible for defining the prioritization of the insights and to assign a confidence level to each one of them. So after we saw that, right, all the building blocks, let's connect them all together. So we do have the supervisor, we do have the data agent, data retrieval agent. We have the detection agents. In that specific case, you can see there are 3 detection agents, and we do have the judge agent. And now, let's see how it all plays together. So it all starts with the supervisor agent triggered, whether by predefined schedule or by observing a change in the policy. The supervisor agent initiates the data retrieval agent, where in turn, gathering all the relevant policy data with external third-party enrichments. The data retrieval agent returns all the collected data to the supervisor agent, which in turn initiates only the relevant detection agent if found to be relevant. In this case, the supervisor decided to initiate all of the detection agent, meaning both temporary, contradiction, and expired rule detection agents. Once these detection agents done executing, and they could do that on a separate time, each one of them can take his time. They are running simultaneously, but they already have some different tasks and different comparison or logics or heuristics. So when each one of them will be done, they will return the found insight into the supervisor. And then the supervisor agent initiates the judge agent in order to review all of the found insights. And this review includes the noise reduction, the conflict resolution, and the final prioritization that we just referred. So once the judge review is done, final insights reported back to the supervisor agent. And ultimately, based on the judged result, the supervisor might trigger a specific detection agent for a retry. Or it actually gets a green light to publish the insights into production environment. Finally, after the supervisor publishing to production, the supervisor returns into idle mode and waits to the next schedule or changes to be made. Okay, so as we moved from the problem to the solution, we saw contextual misconfiguration can open the door to many new risks, right? And how AI can actually step in order to help us both find them, spot them, and to fix them early before they are escalating into a major issue. In that way, it's like having a contextual garbage collector. Quietly and systematically sweeping away those hidden misconfigurations before attackers even know they are there. This is very important. And this is actually the journey that we're taking today. It's just the starting point, a glimpse into a smarter, more proactive way of thinking about security in the new semantic era. Thank you.
Have you looked at integrating it with any vulnerability scanners like Tenable or something, and then being able to do like a risk score for rules. Because that's one of the things we struggle with is it's patched today, but I don't really know in 6 months how secure your data will log is.
Yeah, I mean, that's actually a great point. I think that this is a two solution running in parallel. I mean, the vulnerability aspect and Tenable, Qualys, Rapid7 will tell you that you have vulnerability. It's scored with a CVSS of 7.5 and some EPSS even with some score. It's a different kind of, let's say, security issues rather than understanding that you do have something that is not relevant in your policy, because Rapid7 or the VAs wouldn't be able to spot that. Maybe they can see it, but they don't run the analysis on that kind of context. So this is definitely an issue, but this is a different, like they are running in parallel. Sure, yeah.
I got the impression from your example it's mostly for firewalls at this point.
Okay, so the mechanism can be run on any policies architecture. In our product, the policy could be firewalls, could be DLP policy, CASB policy. Every security products essentially will include some semantics about the rule name and the description. Firewalls are the best case because it's most populated. It has hundreds of thousands of rules. It's really dependent on the customer. And this is a very low-hanging fruit to start with, because we are seeing that misconfiguration. Like we have some policies with like 150,000 rules. We know that the customer wouldn't be sure that every of this rule is relevant or not. And this is why firewall is the best case to start with, but we are taking that approach to basically every policies that we are delivering.
But you're just relying on the words, or do you actually integrate the source of evidence, like, let's say, the firewall logs or the Windows event logs if you're auditing that identity or something?
Yeah, it's a great question. But I think that traditional configuration are being there for years, right? Trying to dig into these services, trying to understand whether this is bad or good. This is past. We are taking that into a different layer. The traditional is still there, but we are going above that. We are trying to not inspect the traffic because we are already doing that. We're trying to give some other perspective, like to solve a blind spot that never been tackled before. Sure. Thank you.
From the government of Alberta. I have a question for you. So what are the gaps and the blind spots we should consider before the existing data with the AI or any of the platform?
So again, the gaps that?
And the blind spots should be considered before the existing data.
So I think that, I'm not sure I follow, but I'll try to answer as much as I understand. The gaps currently that we are seeing is about best practices, how actually they are using that. Unfortunately, it's very hard to educate those specific IT systems that essentially we know that they are super busy. They, on their desk, they have thousands of tickets. And this is why this, unfortunately, is still gonna happen. So just a proactive. So, sorry, we can take it.
I'm sorry, I'm gonna have to.
You're shutting me down.
After we wrap up, maybe
Yeah.
outside. Yeah. All right. Thanks, Naor.
Thank you.